In this video, I'm going to take you through the steps on how to construct a truth table for compound propositions. We often do this when trying to show equivalencies between different compound propositions. So I'm going to take you through this step by step on how to create a truth table for compound propositions, which we often do to demonstrate equivalencies between different compound propositions. In terms of the number of rows needed, you will need a row for every possible combination of values for the compound propositions. And essentially what we're saying is, however many propositions you have, you're going to take 2 to that number, because each proposition can either be true or false, and so we need a row to show each of the possible combinations for the propositions. In terms of the columns, you'll need a column for each propositional variable. So again, whatever this number is, you'll need a column for each of those. You'll need a column for every expression that occurs in the compound proposition, and you'll need a column for the final result, usually at the far right. So we can end up having quite a few columns. It's also important that you know the order of operations. So quite often you'll see things that have parentheses around them that make it very easy for us to see the order of operations. But if not, be sure that you understand this table. This table shows us the precedence or the order in which you should use those operators. So step 1, and we're going to be using this specific example. And again, this specific example, I did not use parentheses for the sole purpose of showing you to make sure that we have the correct order of operations and do everything exactly by the book. So we have P or Q, and then we have an implication. So if P or Q, then not R. So again, even though they're not here, we're essentially saying this is happening first, according to our order of operations. Then we've got our implication. So if P or Q, then not R. That's how I want you to think about that. So the first thing we would do is, just as we have been doing this, we are pros at step 1. Construct a column for each proposition, P, Q, R. And you can even put in the rows now. So again, we have 3, so it's 2 to the 3rd or 8, and I have that on the next slide, but you get the idea. You can go ahead and make the rows now if you'd like. But you need a column for each proposition, P, Q, R in this case. Then we're going to create a column for each compound proposition. So when I say that, what I mean is I'm looking at this part of my compound proposition, and I'm looking at this part of my compound proposition, and then I'm going to create a column for the final result, which is the whole kit and caboodle. So that's all of the columns that I need. So you can see how this might very quickly become several more columns. But right now we have 6 columns. And again, we have now 2 to the 3rd or 8 rows. So this is what our compound proposition truth table would look like. So just to recap, we have 1, 2, 3 columns that give us just the propositions. And again, that's that part that's going to occur on the left side. Before we actually do any thinking, we just have to give all of the different combinations that are possible. And then we've got the middle portion of our truth table that includes all of the parts of our compound proposition. And then we have the right-hand side that is going to show just the results. So this is the parts, this is the results, and this is the combinations. So that's all. Once you have everything set up, then of course you just have to start filling in the spaces. So notice I've cheated a little bit. I went ahead and filled out the left-hand side of our truth table. And again, particularly if you're one of my students, this is how I'd like you to do this. Put all of the truths together, put all of the falses together in that first column, and then true, true, false, false, true, true, false, false, and then this alternates. True, false, true, false, true, false, true, false. So for my students, that is exactly how I would like you to do it. It makes it much easier when I'm trying to check the right-hand side of your table. So now let's work on that middle part of our truth table. And again, you can press pause and go through this on your own without me, and then just check your work on the next slide. That would be just fine as well. So here I'm going to start with, this is P or Q, and that means either one must be true. So P or Q, notice both true, so that's a true. Both true, so that's a true. At least one true, yes. Yep, at least one true there. Yep, at least one true there. Yep, at least one true there, and then here's falses. So all trues and two falses. And then we have not R, so that one's going to be very easy. I'm just going to take R and I'm going to change the truth value. So true becomes false, false becomes true, true becomes false, false becomes true. You get the idea. So that's that middle part where we're basically just finding all of the parts. And then our final solution will be putting it all together. So we're saying if P or Q, then not R. And remember, an implication, which is what we're dealing with here, is true. If we've got two trues, so true implies true, or if the first part of our implication, the hypothesis statement, is false, then our result is going to be true. So looking at these first 6, where P or Q is true, I'm only going to get a true value if not R is true. So that's going to be true here, and true here. And the rest of those are false. And then for the false statements, or the false hypothesis, remember we're going to end up with true. So I get false, true, false, true, false, true, true, true. And of course, checking our work to make sure we know in fact what we are doing. And we see that we get false, true, false, true, false, true, 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 and we did just fine. Here's one practice for you to do. I'd like you to create a truth table for the implication if P or not Q, then P and Q. So I'd like you to press pause and actually try the whole table. Obviously, I've given you the number of rows and columns that you will need. Once you are done, press play to see how you did. Now notice I only have 2 propositions. I have P and I have Q. So on that side, I'm just going to have true, 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 false, false, true, false, false. That's that left-hand side where we don't have to do any of our thinking. Then I'm going to have, this is a new one that we haven't done before, but this is something that I'd like you, or you need to be doing, not just I'd like you, but it needs to happen. If you have a proposition that is negated, you also have to create a column for that. So not Q is going to be false, true, false, true. So it seems kind of silly, but it's something that you need to do. And you'll also then, of course, need all of the other parts of this. So I'm going to need P or not Q. I'm not going to put the parentheses on there. P or not Q, and then I'll need P and Q. So that's all the stuff in the middle. And then, of course, this last one is going to be our result, which is P or not Q, or if P or not Q, then P and Q. So that's going to be our final result. Let's go ahead and fill in the other parts of the middle part of our table. So I have P or not Q, and remember this is the or, and this tells us that I need a true for either P or for not Q. So looking at P and not Q, I do have one true. Looking at P or not Q, I actually have 2 trues, but I just need one. Looking at P and not Q, I have two falses, so that's a false. And then P and not Q, I do have at least one true. Then I'm going to look at P and Q. Remember, this is and tells us that they both need to be true. So now I'm looking at not P and not Q, but just P and Q. So they both need to be, and that's true. And then they both need to be, and that's false. And they both need to be, and that's false. And they both need to be, and that's false. Now, my final result is I'm looking for the implication. Now, remember, the implication states that if the hypothesis, this guy, is true, then this guy, the conclusion, must be true. So that gives me a true here, and a false here, and a false here. The other part of it says, hey, if the hypothesis is false, then it's going to result in a true. And so this is my final solution. True, false, true, false. Up next, we are going to be translating propositional logic statements. So we'll either be given a propositional statement and we are to write it as an English statement, or vice versa.